Uh, Please try to take one or two more classes because already I have announced that I want to give a 1 week gap so the winter vacations can be merged. We were doing last time this 2 3 classes. We had started this nuclear physics. We started it actually before midterm, then we stopped it and we started it again. Give a heading smoke detector. Smoke detector is a smoke detector is a safety device. You must have heard about fire alarm. So similar to fire alarm, these devices are there in the rooms, in the roofs also. And if smoke comes, because normally smoke comes first and then fire comes. So smoke alarms, smoke sensors are actually much better in aeroplanes, in buildings, in hospitals, they are everywhere. Smoke detector is used to detect the presence of smoke. Now, this is my first concept. Smoke detector is a safety device and potentially it is a sensor for fire also because after the smoke, fire can come. So you have to copy the first title heading. You have to copy this. Smoke detector is originally a type of fire sensor, but or potentially it's a smoke sensor. Now, remember this concept. This chapter is radioactivity. We are not concerned with the actual working of the smoke detector. This topic is actually as a side heading, how we can use ionizing effect of alpha particles, beta particles in these devices. Remember alpha particle, beta particles, when they pass somewhere, they create ions. This is called ionization. So smoke detector works on the principle of ionization. So suppose there are some atoms here and suppose an alpha particle is coming from here. Alpha particle has a positive charge. When alpha particle pass through this medium, when alpha particle pass through this medium, look at this medium. Look at this. When alpha particle pass through this medium, the medium particles are ionized. Medium particles are ionized. So ionization is a feature of alpha beta particles. They apply the same approach and you have to see the basic idea. This is a smoke detector. When smoke enters the detector, it passes through a medium. Look, this is a smoke detector. It is a smoke detector and we have a alpha particle source here. And in between here, there are ionized particle. Look at ionized particle. Alpha particles have ionized the region between the plates. Alpha particles have ionized the region between the plates. Now there is a current because we have placed a battery. What happens when smoke enters this tube? When smoke enters this tube, look at the smoke is entering. When smoke enters this tube, smoke particle absorb the ions. Smoke particle means carbon particles. Carbon particles absorb the ions, and now the ions are gone. Current is also decreasing. When current decreases, when current decreases, automatically the sensor will pick it and the alarm ring. This is how a smoke detector works. Look, I repeat the concept. This is a smoke detector. There is a alpha particle source between the plates. Between the plates there are ions. How the ions are there? Alpha particles have ionized the region between the plates. Alpha particles have ionized the region between the plates. When uh, ions are there, we create a current from the battery. We create a current. When smoke enters, when smoke enters between the plates, smoke particle absorb the ions. Once the ions are gone, current decreases. When current decreases, alarm rings. When current decreases, alarm rings. This is how a smoke detector works. So after copying the first concept, you have to give a side heading structure. So give a side heading structure. And then copy this diagram. Can you people hear me? Please reply if you people can hear me. Asad, can you hear me? Okay. I have explained the procedure. I have explained the procedure, and the smoke detector is actually fitted to the ceiling. The alpha particle ionize the air between the meat plates. Alpha particle causes ionization. When smoke entered, smoke particle absorb the ions, and this reduces the current. Then alarm rings. Now look at this procedure. Please copy with me the procedure. A current is produced by the circuit. The smoke particles absorb the ions. Alarm rings. Copy this working procedure. The half-life of the isotope with a household fire alarm should be long enough to avoid regular changing of the source. Now, this is a concept which will be next concept for today. You have to select an isotope. So you select such an isotope which is having a long half-life so that it doesn't go down very soon. So you don't have to remove and don't have to replace the radioactive source earlier in the system. So you have to copy this concept now. Now, give a new heading, carbon dating. Give a new heading, carbon dating. Now, this is a new topic. We are but the new means this is our next topic for today. It doesn't mean it's new, not new in syllabus. Now, there are two isotopes of carbon. There are two isotopes of carbon. One is called carbon 12 and one is called carbon 14. Now, make a concept that carbon is a compulsory element, and you people may, I think all of you people take chemistry also. So we all are organic, and organic means carbon. So carbon is present in all of us. Carbon is a complementary part of every one of us. Carbon is present in our bodies. Now, when we analyze carbon in our bodies, we always find two carbons. One is carbon 12 and one is carbon 14. Carbon 14 is radioactive. It's not stable. It is present in every one of us, but as its half-life is very long, its half-life is approximately 6,000 years. So it's a very slow element. It doesn't harm us, but it is present in everyone. Now, when a living body is respiring, it's taking in carbon, and obviously there is a balance. So the ratio in every living body for carbon 12 to carbon 14, this ratio is constant. Now, what happens if a living organism dies, finishes respiration, then after some time, the ratio begins to change. Why? Because carbon 12 is not changing, but carbon 14 will begin to decay. So this is how in our body, there is a radioactive isotope which begins to decay. After a long time, carbon 14, after 6,000 years, carbon 14 decreases to half of its original value. So when they get any old remain like a dinosaur bone or any old fossil, what they do, they estimate the actual ratio of carbon 12 to carbon 14. For example, just for explanation, you suppose that it is 100:4 in real. Now you find a bone, and when you open the bone, you found 100:1. So it means that carbon 14 has become 1 upon 4. It means 1/4, twice decayed. So if it is decayed twice, because 4 times decrease, so you can estimate that this this bone is 12,000 years old. This process is called carbon dating. It's a very famous process. Lot of work has been made on Egyptian mummies and dinosaurs and the old skeletons from the earth under seawater. Carbon dating is a very successful method for living organism. I have explained that it actually depends upon carbon 14. It depends upon carbon 14. So carbon dating is a process that dates any object that was once alive. You have to copy this. Carbon 14 is a natural radioactive element, and we can say it is present in every living body. There are two radioactive isotopes. Now, question comes how carbon 14 actually form, because it's a radioactive isotope. Nitrogen in air actually that converts into carbon 14 by a nuclear transformation. Originally, carbon 14 is not present in the universe, in the sorry, in the air. It is formed by a reaction. So now you have to copy this screen. Now, how this process start? Cosmic rays are coming from the space. Cosmic rays are coming from the space always. These rays contain neutrons, and these neutrons strike and they convert into carbon 14. So this is actually a natural process which generate carbon 14 due to carbon cycle. This carbon 14 reach our body, and then it becomes the part of it. After the death of a living body, death of the living body, these carbon 14 begins to decay and it will reasonable. This ratio is known and this ratio is constant when the object is living. But when the object dies, respiration is over, carbon 14 begins to decay. You have to copy this now. Now, what happens when you get an old skeleton or a old piece of bone is discovered? We use a Geiger counter or a spectrometer. This is a issue like a mummy is found, some bones are found, or some skeleton is found. We can analyze them. So when a sample is obtained, the ratio of carbon 12 to 14 is determined using GM2, and then using half-life method, the age of the sample can be obtained. You have to copy this procedure. So for example, we have a ratio of C12 to C14, say 100 is to 1 is the original ratio, and you find a sample of existing material, old remain, and you see that it is now 0.25 in place of 1. So you can make a ratio and you can solve it in this way. In this way, you will come to know that the half-life is 6,000. So as your N is coming 2, it will be 12,000-year-old specimen. Now you have to give a heading, health hazards of ionizing radiations. Give a new heading, health hazards of ionizing radiations. Radiation can cause damage of cells. They can cause mutation and cell death. It can also lead to cancer. Intense exposure to ionizing radiation may produce skin or tissue damage. So these are the common issues. Whenever, may God not, you have to go to a hospital. So the doctors say if any X-ray is going on or any other test of that type, doctors say you should not be standing there except the patient. Why? Because these radiations are invisible and they can cause severe problems. So now you have to copy this screen. These are the important problems of the radiation, ionizing radiation.